Hi, in this part of the video, I'll discuss about functions, brief about functions, or you can say introduction to functions. And I'll assume that this is the first time you're learning functions. So I'll start from the beginning. So the function is basically it's a relationship between input and output. So this is how we express functions, that there is an input that goes into function and what we get out of it is output, and in the center sits the function. So basically function relates input with output. It's a relationship between input and output. Now I'll give you a brief example. You have seen a juicer at home. So what it does, it takes a fruit, right? It can be apple, it can be mango, it can be orange, or it can be vegetables also, fruit or vegetables. So this is going to be input in the juicer, right? A vegetable or a fruit, and what we get out of it is a juice. So this is an example of, I would say, one variable function, because what we are inputting into this juicer is one thing. This is, though you can put multiple things, but this assuming it can take only one thing, it can take a fruit or a vegetable, or one fruit or one vegetable. So this is an example of a function which we say is a one variable function, which can take one variable to produce output, one variable function. And we can have a function which can take more variables, right? So instead of giving one variable, we can have multiple variables, right? For example, if we take an example of a phone, how we make a phone. If we have to produce a phone, then obviously we have to put a screen. We have to suppose it's an assembly machine where we are producing a phone, so there should be a screen that we have to fit on the phone, and there should be a the circuitry, or you can say the motherboard, and the the where all the chips are installed. So you can say the circuit, right? And then the battery. So everything has to go inside to make a phone. So function can take a single variable to produce output, or function can take multiple variables to produce output. So generally the function with a single variable, this is how we represent them. The output, suppose if I say output I represent with a variable y, and input with a variable x, and this function I represent with f. So this is how we write, this is how we write this thing. Y, which means output, is a function of input variable x. That's how we represent. But if we have a multi-variable function where output is, again I say y, and input, it can be x, x1, input can be x2, input can be x3. So input are multiple. There are multiple input to produce one output. So basically in this whole course, I'm not going to discuss about multivariable function because it is not in the syllabus. It's not in syllabus of any exam. When you go to college first year, you will study about multivariable functions. So here we'll just focus on one variable function. So one variable is input into a function to produce one output. So now I've just focused on one variable function. This is how we represent one variable function. There's a box and I write f here, the function I represent with f, and it can be any machine. It can be like a machine. You can think of it as a machine which can produce output, and output we represent by y, and input by x. So x, or you can say input. So input, so generally we use x and y variable to represent input and output, but it can be any variables. So this is a function of y is a function of x. So it can be, you can represent function, you can say y is equal, g is another function. Instead of y, I can say function is g, and input I can say t. So it doesn't matter what variable you use as input. To represent input, you can use x, you can use t, but mostly generally if by default we always take input as x and output as y and function as f. but function can be, in case there are multiple functions are to be represented, we take x, we take f, we take g, we take h, so we can use different variables. We can use capital letters also. You can say my function is capital Fx, so it depends. Right, so I'll give you some examples of a function. So like, you know, I'll take very simple examples because we're studying functions in this course, so you have not been exposed to many functions, so I'll take very simple examples. So the function which I'm sure you would have heard of is a linear polynomial or a linear function. So I'll take an example of a linear function. So this is my y equals to x plus 1 function, which we also called as a linear polynomial or a linear function. So this is what happens in a function. I replace x in this linear polynomial x plus 1, which generates my output y, and this is how we represent. So इसको आप x plus 1 भी बोल सकते हैं, or you can say this is fx function which is represented as x plus 1. So same thing, you say y equal to x plus 1, output equals to x plus 1, or you can say my function is x plus 1. It's the same thing. कि जो output है, this is, you know, this is output I can represent with fx, function of x is coming out. This is like this is input, and this is my output. This is my finish good. This is raw material, x is raw material, and fx is my output. So, and this is also output, we also represent a y. So it's the same thing, you know, either I can say y or I can say fx. So this is my function x plus 1. Now I'll take an example how this function works, how it generates a value. It's a very basic and fundamental thing. I know you might know it, but you know, let me still go through it. So this is my input. If I replace the input x equal to 0 into this function, so मैंने x की जगह 0 throw किया इस function में. Now what output I'll get if I put a raw material 0 into this function? So output is y equals to 1. That's what we have to do. You replace x equal to 0 into this. So what this function will do, it will replace 0 in place of x, and output is 1. कि जहाँ भी x था उसकी जगह 0 replace कर दिया, because input जो आ रहा है वो 0 है, right? And another example I take is, you know, I take x equals to 1 and output is 2. So basically the function is you increase the value by 1. Whatever is coming inside, you increase by 1. So it's 2. If I say value 10, then output is 11. If I say value is 100, then output is 101. So that's how this function works. It increases the input by 1. It increases the input variable by 1. So another thing I want to introduce here is this variable x is also known as independent variable. Because and let me say this is y is dependent variable. So we use this naming convention for x and y. X is a dependent variable, x is an independent variable, y is a dependent variable. And this is very obvious because, you know, we are choosing x first and then we get y. Like first of all we should have a raw material, then only we can get a finished good. So x is like a raw material, right? And then y is a finished good. So y is dependent upon x for values. X नहीं होगा तो y नहीं होगा. We need to set x first, then only we'll get y. So that's why we say y is a dependent variable and x is independent variable, because independently we choose x first and then we get y out of it. So this is one example, you know, which is generating output. So another example can be, you know, y equals to, this is square root of x. In fact, this is what we call as a positive square root function. Positive square root. So you can, one thing you should know before I, you know, continue further, that this is, it's not a square root, it's a positive square root. So what I mean to say is, if I say root of 4, it is not plus minus 2. Generally the root of 4 means those numbers whose square is 4, right, are known as square roots of 4. Root of 4 or square roots of 4. So it is 2 and minus 2. Generally if you say square roots of 4, it is 2 and minus 2. But in this case this is positive square root, so it is only 2. Like, take another example. If I say square roots of number 9, then square roots of number 9 is, this is positive square root of 9 and this is negative square root of 9. This is because if we take square of this we get 9. If we take square of this we get 9. So these are square roots of 9. This is what we say as positive square root, and this is what we say as a negative square root. So this symbol is positive square root and this symbol is negative square root. So always remember that this can only generate positive value. This is positive square root, so it can generate only 3. यहाँ पे भी देखो, यहाँ पे ये part, this will generate 3 only. If there's a minus sign outside, that's why it becomes minus 3. Otherwise, it is square root of 9. This is positive square root of 9 is 3. बाहर minus लगा हुआ इसलिए minus लग गया. So that is very important. So in this case, you can understand that y can only take positive values. Y cannot take negative values because we're taking a positive square root of the values of x. So y will always be positive. So if I draw this table, input output table for this root x function, some examples, so that I'll take here. So this is x, this is y. So if I replace x equal to 0, I get y equal to 0 because square root of 0 is 0. If I take x equal to 4, I get y equals to 2. Again, I remember that it's just written as a positive value. If I take 9, it gives 3. If I replace square root 3, then y is square root of 3. Y is square root of 3. Either you can write it like this, or you can write the square value of square root of 3, which is 1.732, like this, right? But remember one thing, if I replace minus 1 value, then this is not going to work. We are not going to get any output. Why? Because we are we are studying the real valued function. We can have the complex function also, but this whole course is about the real numbers. This whole thing is about the real number. So x is a real variable, y is a real variable, and we're defining a real function which is connecting real value of x with real value of y. So x भी real है और y भी real है, और जो function है वो real values को connect कर रहा है. That's why we call this function as a real valued function, right? Real valued function. So remember that now if I replace x equal to minus 1 into this operator, this it's like a operator. We can also call this function as an operator. We use the operator word. I replace minus 1 inside this function. If I replace minus 1, it becomes, what this function will do. This function is root of x. It replaces x by minus 1. It becomes root of minus 1. And root of minus 1 is not a real number. So this function is not going to return anything out of it. Nothing will come out. कुछ भी बाहर नहीं आएगा. Because root of minus 1 is not a real number, and this function can return only a real value. So minus 1 is something, we cannot replace here. Minus 1 should not be, this function does not accept negative values, right? The values it can take, the values here, the x it can take is only non-negative values, 0 or more, obviously non-negative values, right? X is greater than or equal to 0, that's non-negative values. So another example, very simple example I take is a square function. I take a square root function. I can take a cubic function, which y equals to x cube is a cubic function. So it's very straightforward. X is coming, whatever value of x is coming, we take the cube of that, right? So if I take few examples, again if I replace x equal to 0, y is 0, because 0 का cube होगा तो वो भी 0 हो गया, x 0 and then y is also 0. If I take x equal to 1, you have to just take the cube of that number. If x is 1, then cube of 1 is 1 cube, and 1 cube is also 1. So again output is 1. If I replace x equals to 2, then y, the value y can take is 8, because 2 cube is 8, 2 cube is 8, 2 cube means 2 into 2 into 2, 3 times, and it becomes 8. So that's how, these functions work. Now, the next thing in the introduction of function is, single valued function versus multiple valued function. Now, single valued function is, I'll explain you like this. Suppose this is how I represent my input, the very typical way of representing input, or you can say x, right? And this is another, I draw this elliptical shape, I say output, or I can also say y. So, and suppose I have some values here, x1, x2, x3. I just take 3 values, and I have values y1, y2, y3, y4 in the output. So in this case, maybe I can take less values. Maybe I can take these values. So see, this is one valued function, single valued function, or another name for this is one valued function, right? Sometimes we simply use a function word. Function means single valued function or one valued function. It means that every value of x, every input variable can produce only one output. This is x1 के साथ खाली y1 ही आ रहा है. If I do this, no, this is wrong. X1 cannot produce two output. X1 will produce only one output, right? If you like whatever raw material you are giving into the machine, it is generating only one output. If you put if you, for example, in a shoe factory, you put a sole, you put a the skin of the shoe, so you're only going to get one shoe, not two shoes. So one input can generate only one output, not two outputs. So this is single valued function, or we can say one valued function. One output, one input means one output, right? So in this case, this is possible. This is possible. Two, right? This is possible. Two input we is giving the same output. This is possible. And x1 output be y1 r, and x2 also is giving output y1, and x3 is giving output y3. So these are the values of x. These are the input. The x is a variable. X is a parameter. And these are the possible values of x. So two values can have the same output, but one value of x cannot have the multiple outputs. So this is fine. This is right. So we call this as single valued function, right? Single value. So in this case also single valued function. So another example of single valued function. So this time I made a small change. So suppose we have x1, x2, x3, and on this side I have y1, y2, y3. So x1 maps to y1, x2 maps to y2, x3 maps to y3. This is again a single valued function. So only difference is that here one value of x is mapped to only one value of y. Here in this case we have an example where two values of x map to one value. This is fine. What is multi-valued function? Multi-valued function is, this is my input. I say x1, x2, x3. On this side I have again y1, y2, y3. So see this, x1 is mapped to y1 and y2 both. See, this is an example. Both x2 and x3 produces y3. This is fine. This is fine. This part is fine. This part is fine because one input is producing one output. But in this case, x1 is producing two output. x1 replace k, and we are getting y1 as well as y2. This is multi-valued function, right? Or sometimes we say not a function. Multi-valued function hai, but sometimes we say not a function. It's a relationship. We use the word. It's a relationship between input and output. It's a relationship between x and y, but it's not a function. Because generally when we in our course in preparation, we always for the exam, we always say that function is the one which is one valued function or a single valued function. Otherwise it's a relationship. It's not a function, it's a relationship. Either you can say multi-valued function or you can say relationship but not a function. तो रिलेशनशिप बोल सकते हैं इसको, मल्टी वैल्यूड फंक्शन बोल सकते हैं, बट फंक्शन नहीं बोलेंगे. फंक्शन वही है व्हेन सिंगल वैल्यूड फंक्शन वेयर फॉर एवरी वैल्यू ऑफ एक्स देयर इज ओनली वन आउटपुट, देयर इज ओनली वन करस्पॉन्डिंग वैल्यू ऑफ वाई. So if you take a simple example, I can give you that which is not a function, which is multi-valued function or not a function, is if I say y equals to plus minus, I just made a small change in the last function we discussed. Y equals to, I put a plus minus in front of square root of x. So what does it mean? It means that if I choose one value of x, I'll get two values of y. If I choose, this time it's a different thing. If I choose x and y, for x equal to 0, y is 0, only I'm getting one value. But if I replace x equals to 1, so the square root of 1 is 1 and there's a plus minus outside, right? So this is function f. So let's represent it like this, y equals to plus minus root of x. And when I say replace x equal to 1, this is how we show it. This is how we write f1. f1 means that I have replaced x equal to 1 in place of x. That's how we show it. That's how we represent it. In place of x, I have replaced 1. And this is equals to plus minus root of 1. And root of 1, as we just discussed, root of 1 is a positive value. It gives a positive value 1. Root of 1 is 1. Because if we take square of 1, we get 1. So square root is also 1. Square root is reverse operation of square. So answer I get is plus minus 1. So you can see for one value of x, 1, I replace 1. One value of x, I replace 1. I get two values of y, plus and minus 1. So this shows that it's a multi-valued function. For one value of x, I'm getting two values. Same way if you replace 4 here, this is an example, 4 here. So I'll get plus minus 2 as output. So 4 means I want to find f4. f4 means plus minus root of 4. And root of 4 is 2, so I get plus minus 2. Multiple values. Right? So another thing I've introduced here. So this notation, you can see this notation. It means that, so I've replaced 4. This is a particular value. It's not a function. It's just one value. Value at x equal to 4. Right? It's quasi represent k. So if I in a function in y equals to fx, if I replace x equal to 2, then I say y equals to f2, value at x equals to. This means that value of the function at x equals to. It means that output that will come out of the operator, the value that will come out of the operator, out of the function when I replace x equals to 2. When x equals to 2, I replace x equal to 5, then I write y equals to f5. It means that value of the function at x equals to 5. The output that will come out of the operator when I replace input x equal to 5. It means that this means that I replace input 5 in the function f, and what I get is f5. So specific value at a specific, right? Y at a value of y at a specific value of x. So again, I told you, it's very, some of the things are very fundamental. You might have done them before, but I cannot assume that you have done it. So I have to go through each and every part. Again, in the introduction, this is the part I'll discuss about the simple function versus a compound function. So simple function is if the function, some of the functions we discussed, like y equals to x is a simple function. It means that, so this is identity function. We use the word identity function also. I replace x into this function, which is x. So it is doing nothing. It's just bypassing that value out. So it is throwing out whatever values we are throwing inside, it's throwing out. If I replace x equal to 1, y is 1. So you can see that, right, for every value of x, my execution is same, right? I am passing it. Let's take another example. Let's take an example of linear polynomial. So y equals to x plus 3. What is happening? I'm replacing x here and I'm adding 3 to that value and throwing that output as y. So whatever input is giving to the function, whatever input is we're giving to this function is adding 3 to that value and throwing it out. And irrespective of the value, if you replace x equal to 1, you get 4 because 3 is added. If you replace x equal to 2, again 3 is added. What we get is 5, right? 3, again 3 is added, we get 6. So this is what we call as a simple function, because for every value of input, every value of x, or every input value, every input, y is doing the same processing. Y is acting in the same way. Now I'll take an example of compound function. We use the compound function word, or another word is piecewise defined. Piecewise defined function. So this is how we either piecewise defined function or compound function. So piecewise defined or compound function means the function has multiple pieces. I'll show you an example. So if I say y equals to or fx equals to, and this is how we use this bracket, curly bracket, and then this is, I say when x is negative number, x is less than 0, then output is you do x plus 1, add 1 to that when x is negative. But when x is either 0 or greater than 0, that's how we represent this. This means that x equal to 0 as well as greater, x equal to 0 or x greater than 0. Together we say x greater than equal to 0. You add 2 to it. So this time, what's happened, this function is doing, it is having a discriminated or behavior or different behavior, or its processing is different. It's not doing the same thing for every value of x. It has a compound. We use a compound word. Pieces we have, when we are joined pieces, we make a compound structure. You know the compound in English word of English meaning of compound, कि जब हमने चीज़ों को जोड़ा है तो compound बन गया, वो जोड़ा है, simple चीज़ों को pieces को जोड़ के compound बना दिया. So here we have two pieces. If you look at that, we have this piece x plus 1 only has to be taken when x is negative, and we have a piece x plus 2 when x is greater than equal to 0. I'll take an example. If I if I value of y at x equals to minus 1, what will be? I'm replacing minus 1 into this function, so it will fall into this category, right? It will fall into this category. Minus 1 के लिए हम ये definition use करेंगे. You can understand this with the help of this operator diagram also. So in this case we have this definition here which says that x plus 1 when x is less than 0, when x is greater than equal to 0, do x plus 2. Now I'm replacing minus 1 here. When I replace minus 1 here, this condition will be checked. X is negative, so minus 1 is given to this function. Minus 1 इसके पास जा रहा है और उसमें 1 add हो गया, तो output will be 0 this time. This is not use, right? This is not use because x is not 0 or positive. But yes, if I replace 2 as input, so this f of minus 1 is 0. Now if I replace 2 as input, I'm talking about f2, I'm replacing 2 as input. If I replace 2 as input and 2 is greater than 0, so this definition will be processed. Not this definition, only this definition will be processed. And we adding 2 to it, answer will be 4. Y equals to 4. So this is, is compound function. I'll take, so basically, this is a compound function. As y equals to fx, I can have multiple pieces. That's why we say piecewise defined function. I say x is less than a is some value, x is less than a, then definition I have to take is f1x. I'm just giving you a structure of a general compound function. If I say x is more than a but less than b, as well as equal to a and equal to b, I have to use this f2 definition. So I'm assuming a is less than b. A is less than b. And then if it is more than b, I have to use f3x. So I've taken an example or a general case where there are 3 pieces in the function, not just 2 pieces but 3 pieces. If there is only 1 piece, then it is a simple function. If there are more than 1 piece, then we say it's a compound function, right? So and here you can see the pieces. Pieces are, this is a about which a is a value about which definition change is taking place, and b is another value where definition change is taking place. A and b, x equals to a and b, we can say junction points where definition change is taking place. Junction points, sometimes we use the word critical points, you can say vital points. So we're just giving name to them. So the common name is we sometimes call them as a critical points. Just but just as the English word to represent them. Junction points, you can use say junction points. So these are the points where definition change is taking place. On left and right of this point, definitions are different. Right? So we'll discuss more about compound functions later, but just to have an introduction here, that for every value of x, y is doing the same thing, y is doing the same processing, then it's a simple function. But based on the value of x, y is using different definition, y is acting differently, then it's a compound function. Like for example, if I take a juicer example, suppose inside the juicer, the machinery is made in such a way that if we input a fruit, then machinery A will act. But if we input a vegetable, then machinery B will work. So because to fruit, it's a different processing. I mean, I'm just assuming, I'm taking a random example. For a juice, for a fruit, it's a different way to take out the juice, but in a vegetable, it's a different way. So, the machine can work in both the cases, but different machinery is to be used. So it's a compound thing. If fruit is coming, then machinery A is used, or part A is used. If vegetable is coming, then part B is used. This is what we'll say the compound function, or a piecewise defined function, but because it has pieces.